In this lecture, I'll show you how to use matrices to determine the rank of players or teams in a tournament. The most famous method is this Coley method. It's a very sophisticated method, and I'm not going to discuss that one here. Instead, I'm going to give you a very basic method that you can extend to many circumstances. In this method, we'll look at two things. The first thing will be the direct wins. That's the number of actual wins that you have in this tournament. And then we'll also look at the rank of the team or the players that you beat. These are called secondary wins, and you can see what they should be. They should be some weight. For example, if you knocked out Joe Frazier, then if you knocked out me, that should only be shameful, being that I'm weak. But if you go against a high-seeded person in your tournament and you beat them, you generally get more weight for that. And so this is a way to include that, is by including these secondary wins. To start off, we need the data from the tournament or a previous tournament, and we'll arrange it in this kind of a diagram. In this case, we had 4 players or 4 teams, and we're looking at the wins, and the arrow means, well, the arrow points to the loser. This arrow between 1 and 2, with the arrowhead over here pointing to 2, means that Team 1 beat Team 2. You see down here, 2 and 5 played each other in 2 games. In one case, Team 2 won, and that's why the arrow is here pointing to 5. 2 beat 5, and the other game, 5 beat 2. The first matrix we construct is the matrix of direct wins, and I've called that D just because it's direct wins. There's no set terminology for this. You could call the matrix, you could name it anything you wanted. Here's the rule, though, for determining the elements of the matrix. It's a piecewise function on the element ij. Remember, I is the row and j is the column number. So aij becomes 1 if team I beat team j. So each one of these rows is a team. Here's team 1, team 2, these are the i's, team 3, 4, and then team 5, of course. And the columns are also the teams, team 1, 2, 3, 4, 5. Now if team 1 beat team 1, well, you don't get a point for playing against yourself, so that's a 0. But team 1 did beat 2. See, there's an arrow like that, so there's a 1 here. Team 1 also beat team 4, so there's a 1 there. But team 1 never played 5, so there's a 0. Team 1 never played 3, so that's a 0. And I just continue down, filling up the matrix. Look at team 4, he's doing pretty well. Team 4 beat team 1, so it has a 1 here. Never played 2, so there's a 0 there. Beat 3, there's a 1 here. Never, it doesn't go against itself, so you leave that one 0. These diagonals are all 0. And team 4 beat team 5, so he gets a 1 right there. And that's your matrix of direct wins. Now I'll construct the matrix of secondary wins, or second order wins. I called that S because it's second order wins. Again, you could name these matrices anything you wanted. And we have a rule for filling up this matrix too, also based on aij. Remembering again, I is your row number, j is your column number. You could call these anything you want. It's the position that counts. The fact that I is first means it's the row. And then j is the second letter here, means that's the column. So you get a 1, aij becomes a 1 if team I beat a team, any team that beat j, and a 0 otherwise. So let's start off with team 1, and you still get a 0 here, although you might say 1 beat 4 who turned around and beat 1. You might argue that you should put a 1 here, but I'm not going to. But look at this case. Team 1 beat 4 who went ahead and beat 3. So there's a 1 here in the 3 column. Team 1 also, has beat 4 who beat 5. So team 1 gets a point in the 5 column. It had a second order win against team 5 by beating 4 who went on and beat 5. Look at team 4. Team 4 beat 3 who went on and beat 2. So we got 1 point for that. beat 1, who went on and beat 2, got a point there, beat 5, who also beat 2, that's 3, and that's why there's a 3 here. And so you fill up the matrix like that, looking for second order wins. Now you add the two matrices together, but you can give them different weights by scalar multiplying the D and the S by any numbers you choose. For example, if you think that the direct wins are very, very important, you might go 5D plus S. This will, remember, scalar multiplication multiplies every element in the matrix. So all the entries in the D matrix would be multiplied by 5. That would give a very high weight to the direct wins, and the second order wins would probably not even make much of a difference in the ranking. You might do something like this, 1.5 times S. That gives a 50% weight, increased weight to the second order wins if you think those are more important than the direct wins. What I'm going to show you though is a case where I'm just letting them be equal, D plus S. No particular weight to the direct wins or the secondary wins. Here's the result for the situation. I'm just adding the two matrices together. And recall that when you add, you go element by element. So this 0 gets added to this 0, and the result is placed there. And now when you're done, you have this matrix here. Remember, you can add these two matrices because they are the same order. They're both 5 by 5s. So now you've produced this matrix, this total matrix, including any weights that you wanted to give to the direct or second order wins. And now you do something that is not a matrix operation at all. It doesn't even have a name. It's just something that you do. You add up all the numbers here. Remember, team 1 was here, the first row, and this was team 5, all the wins and second order wins for team 5, team 4, okay, in the fourth row. So you just add up all the numbers in the row. And when you add them up, you get the ranking for the teams. Obviously, team 4 is way out ahead with 7 points, and then tied for second place is team 1 and team 3, and 2 and 5 are tied for third place. You might not have ties in your tournament or your ranking. In fact, you hope you don't, because what do you do about those? At any rate, that's the method. It's a very simple method, but you could adopt it to many different situations, and it is the basis for those more sophisticated methods.